Alright, well today we're going to finish up 5-4. We're going to look at a different way to divide. Yesterday we looked at long division of two polynomials. And today I'm going to show you kind of a shortcut here, but it doesn't work in all cases. So if you're going, why did you just show this to us yesterday? This doesn't always work where long division will. So it's just a process you got to get down. This is the same problem I did at the end yesterday, long division wise, and I believe, let's see if memory serves me correct, we got 2x squared minus 3x plus 1. So hopefully I've got that right because I'm going off memory. I'm going to show you another way to get that answer. First, look at your divisor and see if you can tell me what makes a divisor equal 0. In this case, negative 3. Negative 3 is what makes a divisor equal 0. Well, what you do is you put the negative 3 down, and then I'm going to do an upside down. Your book's got a little different. I don't know, I like it the way the other books used to have. It's just an upside down big long division bar. And then I want to leave, think of two rows here. I want a row on top and a row on the bottom above this long division bar. So there's going to be some numbers that go here in a row. I want to leave space is what I'm saying. So what goes on top? Take the coefficients of your dividend and put them on top. But be aware that just like yesterday, if you're missing some power of x, you need to put a 0 there. So here I got x to the third, x squared, x, and then a number. So I don't need to put any zeros in here. I just need to put 2. That's my first coefficient. 3, negative 8, 3. So I'm just putting these numbers, these coefficients down. Didn't have to fill in any gaps, so I didn't put any zeros. Here's how the process goes. You drop down the first number, then you multiply. Negative 3 times 2 is negative 6. Then you add. You get negative 3. Then you multiply. Negative 3 times negative 3 is 9. Then you add. You get 1. And then you multiply. Negative 3 times 1 is negative 3, and then you add and get 0. Well, if you take a look here, I've got the same numbers right here, 2, negative 3, 1, that I have up here. So our answer is staring us in the face. How it works is your first number is always 1 less than your initial degree. So here our initial degree was 3. So this first number is going to be x squared. Then it's going to go x. Then you have your plain number. And then there would be a remainder at the end. Well, the remainder in this case is 0. And again, that tells me that x plus 3 is a factor of that 2x cubed plus 3x squared minus 8x plus 3. So if I asked you, is x plus 3 a factor? You'd say, yeah, because I get a remainder of 0. So that's a synthetic process. We'll go through that a couple more times. And then we'll do the remainder theorem. So what makes this equal 0? 2. So it's what makes that equal 0? What makes divisor equal to 0? 2. That's what you write down. So I have 2 upside down division bar. And then I just put my coefficients in there. It's 1x cubed. It's 2x squared. It's negative 6x. And it's negative 9. Drop the first one. Multiply. Add. 2 times 4 is 8. Add. 2 times 2 is 4. Add. And you get negative 5. So this one, if I asked you, is x minus 2 a factor? You'd say no, because there's a number at the end that's not 0. You have a remainder, so therefore this is not a factor. You can still divide it. We have the answer staring us in the face. The answer is, instead of x cubed, it's 1x squared plus 4x plus 2 plus the remainder is negative 5, and don't forget to put that over your initial divisor of x minus 2, just like we did yesterday. If you wanted to make this a minus positive 5 over x minus 2, that would be fine. Okay, one more. This one's a little bit different because you skip from 4 to 2. So when you punch these in here, you don't go 7, 3. You go 7, 0, 3. Because you have 7x to the fourth. Then you don't have any x cubes. You have 3x squareds. You have 5x's. And then there's a -1. What makes this equal 0? -1. So that's what I put out here. It's always what makes that equal 0. That's what I put out there. Drop the 7. Multiply. Add. Multiply. 3 plus 7 is 10. -1 times 10 is -10. 5 plus -10 is -5. Positive 5. -1 plus 5 is 4. So it's just the same pattern. Add, or drop it, multiply, add, multiply, so on and so forth until you're at the end. So these numbers at the bottom represent the coefficients of my quotient, my answer. I had x to the fourth, and I'm dividing by x, so it's going to be x cubed. If I took x to the fourth divided by x is x cubed, so it goes 7x cubed minus 7x squared plus 10x minus 5, and the last one is your remainder. And our division, we divided by x plus 1. Our divisor is x plus 1. This one, x plus 1, is not a factor because, again, we had a remainder. So if you want to show something's a factor, you can run it through synthetic, because you have a few problems like that in your assignment. Run it through synthetic like this, and if you get a 0 at the end, you'd say, yeah, it's a factor. Here we don't have a 0, so it's not a factor. Okay, then the second thing and final thing is the remainder theorem. The remainder theorem goes, basically says this. You can use synthetic. So we got polynomial p sub x. So here's my polynomial. The degree is greater than or equal to 1. The degree is 5. And it says if you divide by x minus a. Well, here I'm not dividing by x minus a, but I can pretend I'm dividing by x minus a. Then the remainder is p of 3. So let's see. So p of 3, p of a. That tells me a is 3. So I should be dividing by x minus 3. So if I was dividing this by x minus 3, I would just put a 3 in. And then put my numbers down. 2. Now that's 2x to the fifth. I don't have any x to the fourth, so be careful. So I got to put a 0. Then I have -4x cubed, positive x squared. I don't have any x's, so I got another 0 on this one. Careful. And -5. All this is saying that instead of plugging in 3 here, instead of doing 2 times 3 to the fifth, minus 4 times 3 to the third, plus 3 squared minus 5. You could evaluate that in your calculator and get an answer. Or you could set up synthetic, and the result is simply going to be the remainder. See, it says the remainder is that. So p of 3, when you plug in 3, it says you get the remainder when you divide. That's all it means. So let's see if I can do this quickly in my head. Drop the 2, 6, 6. 3 times 6 is 18. Add, I get 14. 3 times 14 is 42. Add, I get 43. 3 times 43 is 129. Add, I get 129. And 3 times 129. Well, 3 times 129 is 3 times 130, which is 390, minus 3, because I don't have 133s. I have 129 threes. So 3 times 130 is 390, minus 3 is 387. And then we add, we get 382. So theoretically, if I do this over here, if I did 2 and then 3 to the fifth is 243. Minus 4 times 27 plus 9 minus 5. That should be the same thing as 382. Here I'd have 486 minus 108 plus 9 minus 5 is plus 4. So that'd be, let's see, I'm going to add these two first. So I have 490 minus 108, and that is 382. Okay? So, I don't know. Which one is easier? Probably debatable. Sometimes it's easier to plug in, like I did on the left, but other times it's easier to run it through synthetic, like I did on the right. I actually had an easier time calculating the right myself than I did on the left, but it'd be personal preference. The whole point here is, though, instead of plugging in, you can just do synthetic, and the remainder is your answer. So I would go ahead and try this last one on your own before you watch me do this, and then you check your answer. Although it does have a fraction, so that makes it kind of tricky. So I want to plug in 1/3. I've got 3, 2, 2, -4, -3. There are no gaps. It went 4, 3, 2, 1 number. Drop to 3. 1/3 of 3 is 1. Add, I get 3. 1/3 of 3 still is 1. Add, I get 3. 1/3 of 3 is still 1. Add, I get -3. 1/3 of -3 is -1. Add, I get -4. There's the answer. Now, I would definitely say that doing 3 times 1/3 to the 4th plus 2 times 1/3 to the 3rd plus 2 times 1/3 squared minus 4 times 1/3 minus 3 is way more complicated than what I just did here. If you plug this left-hand side into your calculator, what should you get? You should still get -4. That's what this should equal. I did it without using a calculator. I did it without dealing with fractions, using synthetic. So hopefully you can see the benefit of using synthetic in this situation in order to basically come up with a value that you plug in to some function. So that's synthetic, an introduction to synthetic, and a little bit about how it's used. Thanks for watching. Have a great day.